Good morning, everybody. We're going to talk today about mixed numbers and improper fractions. You may have seen these before, but let's make sure we remember what they are. So let's start with mixed numbers. A mixed number is called a mixed number because it's a mix of a whole number and a fraction. It's a whole number with a fraction part. Whenever you see mixed numbers, you know you're going to have something that's more than a whole because it's got at least one whole along with some sort of fractional part. So if I look at these to see what they represent, well, in this first case, if I look at the wholes, I have one whole here, one whole circle. And if I look at the fraction part, it looks like this fraction is a circle that was cut into three pieces, and I have two of the three. So the mixed number here would be one whole and then 2/3 of another one. Okay? For here, in this case, I have two wholes. So the whole number part is 2. And then if I look at the fractional part, I have 1, 2, 3, 4, 5 pieces. And it looks like there's one missing. All right, so 5 out of 6 is my fraction. So this would represent 2 and 5/6. Please note that this is more than 2, but not quite 3. Right? Anytime you have a mixed number, it'll be more than whatever the number says, but not quite enough to have that number one higher. Okay? Just like this one is more than 1, but not quite up to 2. It's between 1 and 2. Okay? All right. Improper fractions are when the numerator is greater than your denominator. So in this case, if I look at these pieces, each of these pieces is 1/4 of a circle. And if I count how many of them there are, there's 1, 2, 3, 4, 5. So this picture is 5/4. As an improper fraction, notice the numerator is bigger than the denominator. Right? That's what makes a fraction an improper fraction. Okay? I have 5/4. You need 4 to make a circle. I have 5. If you kind of picture in your head, you can make a full circle with these, and then be the one left over. So this still, like mixed numbers, this is going to be something more than 1. Right? Anytime your numerator is bigger than your denominator, your number is more than 1. Okay, so these are kind of the two ways to represent numbers that are bigger than 1, either as mixed numbers or as improper fractions. Okay, so let's talk about switching back and forth. So if you're going to convert a mixed fraction to an improper number, here are the steps. Please be writing down these steps. Step 1, multiply your denominator by your whole number. Okay? So if I look at this example, I have 3 4/5. I want to make this an improper fraction. So I'm going to start by multiplying the denominator by the whole number. So I'm going to start with 3 times 5. Okay, 3 times 5 is going to give me 15. Okay, then I'm going to add that product to the numerator. So I'll write that over here. So 3 times 5 is 15. Okay, I'm going to add that to the numerator. So 15 plus the numerator here is 4 is going to give me 19. Okay. Then I'm going to place my final answer over the original denominator. So in this process, the denominator is not changing. Okay, what I want you to think about the denominator as, it's how big your pieces are. So that part isn't changing. Right? So how many pieces is your circle cut into? That's staying the same. Okay, so the denominator never changes, but the numerator becomes 19. So you have 19/5 as my improper fraction. Okay. Now, why that works is because we're first going to, when we multiply the whole number times the denominator, we're figuring out how many pieces there are in my wholes. Right. So let's say I have 3 whole circles here, or 3 whole pizzas, if you're thinking about pizzas. Well, if they're cut into fifths, if that's 5 is my denominator, that means I'm cutting each circle into 5. Right. So if each one of these is cut into 5 slices, and I have 3 whole pizzas here, well, 3 times 5 is 15. Okay, that's why we start by multiplying these. That tells us how many pieces we get from the whole pizzas, from the whole numbers. Okay. Then we're going to add on the 4 because in addition to these 3 wholes, I have 4/5 of another pizza, right? So this one is also cut into 5, and I have 4 of those pieces. Okay, so we multiply to get how many we get from the whole, and then we add the fractional part for how many pieces we have total. And then the size of the pizza stays the same, so we get 19/5. Okay, so let's do this first one here together, and then I'll see if you can do the next 3 on your own. Okay, so 5 and 1/5. We start out by multiplying. 5 times 5 is 25, and then plus 1 is 26. Denominator doesn't change, so I get 26/5. Let's check it. 26/5. There we go. All right, so go ahead and pause the video now. Try to figure out what improper fractions those next 3 would be, and then we'll unpause and see how you did. Okay, welcome back. For 2 and 2/3, we do 2 times 3 is 6, plus 2 is 8, so we would get 8/3. Okay, hope you got that. For 6 and 3/4, we do 6 times 4 is 24, plus 3 is 27, so we have 27/4. 27/4. You might be noticing this is another thing where having your times tables memorized would be very, very helpful. Make these go faster. Okay, 4 and 5/6. If I do 4 times 6, I get 24 again. Plus 5 is 29. So I get 29/6. Bottom does not change. 29/6. So these are all those mixed numbers as improper fractions. Okay, let's talk about going the other way a little bit. And let's start by looking at a little bit of a model here. So if I look at this picture, I got a bunch of different pieces of a circle. They're all the same size. If you visualize this a little bit, you can picture it would take 3 of these pieces to make a whole circle. Okay, so each of these pieces is 1/3 of a circle. Okay, so if I count, I have 1, 2, 3, 4, 5, 6, 7 of them. Okay, so I have 7/3 of a circle. Okay, again, the bottom numbers tells you how big your pieces are. It tells me each piece is 1/3. And top tells you how many you have. I have 7/3 of a circle. And well, if I do a little bit of rearranging to try to get this as a mixed number, I see I can put these together to get a circle. I can put these together to get a circle. And then I have one piece left over. So I can make 2 whole circles plus 1/3 left over. Okay, so as a mixed number, 7/3 would be the same as 2 and 1/3. 2 wholes and then 1/3. Okay, so the way I can do that when given a number is you start by dividing the numerator by the denominator. Okay, so remember, because we're dealing with improper fractions, our numerator is going to be the bigger number. So this is taking the improper fraction 12/7. So we want to see how many times 7 goes into 12. That'll tell me how many whole numbers I can have. Okay, so 7 goes into 12 one time. Okay, and it has, I wrote this here, it has a remainder of 5. So it goes in one time with 5 left over. So the number of times your numerator can be divided becomes the whole number. Okay, total divided by 7 is 1. And your remainder becomes the new numerator, because that's how much is left over. The denominator stays the same. So it went in one time, and I had 5 left over. So it's 1 and 5/7. Again, the denominator is staying the same. Okay. If we look back at this example, we see when we had the 7/3, 3 goes into 7 2 times. That's why I can make 2 circles with 1 left over. So I get 2 and 1/3. Okay. Let's try a few of those. Again, we'll do the first one together, then I'll let you give the others a try. So 14/5. 5 goes into 14 2 times. All right, 5 is 5, 10, 15 would be too many. It goes in 2 times with 4 left over. So it's 2 and 4/5. All right, I'm going to pause the video here, see if you can come up with mixed numbers for these, and then we'll unpause and check. Good luck. Okay, welcome back. 9/2. For this one, 2 goes into 9 4 times with 1 left over. So that's 4.5. For 12/3, this might have thrown some people off. 12 goes in, 3 goes into 12 4 times exactly. Okay, so sometimes an improper fraction will just give you a whole number. There's no fractional part of this because there is no remainder, right? It's just 4. Okay, 11/4. Well, 4 goes into 11 2 times with 3 left over. So 2 3/4 for that one. All right, that's all I got for you today. Good luck.